So we can consider tonight a talk on like what is databases for dummies or databases for people who've never heard what a database is, something like that. But if I was to ask you what is a database, what would you, just off the top of your head, what would you think of? Any ideas? Because you hear the word a lot, right? Like you log into Facebook and you forgot your password, they want you to contact the database administrator, you know. Well, they would just send you a new password, but you know, if something goes wrong with some account on the website, a lot of times they just want you to call the database administrator, you get that message on the website. Well, anyway, just off the top of your head, what do you think a database is? A book of records? Okay, actually it's interesting you use the word records because we're going to be using that word. But yeah, it's basically like a collection of organized data. I mean, there's official, you know, database definition, but it's a collection of organized data that is related to some application. And it's usually meant for going and searching the application, searching the data for data that you might need. So this is, I think, off of Wikipedia. So a database is an organized collection of data, today typically in digital form. The data is typically organized in model relevant aspects to reality, for example. You could ask questions like, are there rooms available in a hotel? So you might have what, you use the word record. You might have what we're going to call records, a record of each room in a hotel, and then some of them may have an attribute that they're occupied and some are not occupied, and then we could search the database to see which rooms are available. We could book a database, which means we change the data in the database to say this room went from being vacant to occupied. And we could, you know, so basically we have a collection of data and then we could ask questions about it and make changes to the data. Okay, so suppose, for example, you wanted to have a list of a piece of paper with your friends, information about your friends, like their email address, their cell phone number, their first name, last name. How would you do that right now? Suppose you were maybe going on a trip somewhere and you wanted to have all this contact information with you. Maybe 10 friends, not a lot of friends. We're going to go through this example and make it get bigger and bigger, but for now, let's say you had 10 or 15 friends and you wanted to keep contact information about them. What would you do? What's that? Where, on your cell phone? Or? All right, but what if you, okay, so on your cell phone is one place to do it. Where, what else could you do?
Just write it down on
Yeah,
piece of paper.
so right, so some choices, I've asked this question before, and some choices are just write it down on a piece of paper, just hope you don't lose it, right? You might use a Word document, so that way it'll look a little more organized, and then you can reprint it if you ever needed to, or if you lost it, you can go print another copy. And then you might put, like, on the Word document, you might say, like, you know, first name tab, last name tab, email address tab, so that way, like, the email addresses all line up and the names all line up, so it looks kind of readable. But then that kind of makes you start thinking, maybe I should use Excel, because Excel is already organized in the columns, right? So we could use Excel and then say the rows are the people, which we're gonna, when we start talking about database, rows are gonna become records, which is what you said. That's the official name in databases for the, I'm sorry, yeah, the rows would be records. And the columns end up being attributes like first name, last name, email, cell, etc. So if we wanted to do that in Excel, if you wanted to do something like that, we could go like this. We could make an Excel spreadsheet, and maybe what we could do is we could call it Friends and open it up. And so Excel naturally follows data that would be in columns and rows, because that's its format. So now we can make a column heading. We could say first, last, and what information do we want to keep about our friends? Email address. What else? Phone. Address. Okay, and then maybe we could make these columns big enough to hold going to put in. So now we could put in, we'll do Seinfeld. Okay, so we'd start putting in data. Right? Just making stuff up here. And we could put in an address. What's the address on the sheet? No. Something like that. Okay. So what we could do here is we can then, and maybe for the column headings, we might highlight them. So it would look, we can make them bold and change the tint so we kind of know that it's a heading. And so basically you're doing something like this, right? We're making a table. So this works under a couple of conditions. You don't have too many friends. If you had 100,000 friends, we might want something better than this, because then if you needed to find a friend, well, you could actually use the find, right? You could use the find tool and find your friend. But another issue starts to come up where we decided we wanted to keep the email address, the phone number, and their not email address, but where they live address. Okay, so here's the thing. Does everybody have one email address? Does everybody have one phone? Does everybody live in one home? Or, you know, do students have a address here on campus and then an address at home and then a house in Florida? You know, could you have multiple addresses? And could you have multiple phones? And could you have multiple email addresses? And if so, how can we change this? Right now, we're still using Excel to run a database. And the point of this Excel spreadsheet is so we'll fill in data, but mostly we're going to look up data. We're going to look for a friend and get their phone number and call them. We'll look for a friend and get their email and call them. So if we wanted to handle the fact that some people can have multiple emails, multiple phones, multiple addresses, what could we do? What if a lot of our friends have 2 email addresses? Let's say they have a cell phone, a home phone, and a work phone. What could we do? There's no right answer. Also, that's another thing. So database systems, like I say, if you take a database course, like the computer science majors take a database course, sometimes it's 1 semester long, sometimes it's 2 semesters long, because there's many things to learn, but there's no right way to design it. And anything we come up with will have advantages and disadvantages. But, for example, what's a way we could record home, cell, and work phone numbers?
Add more columns.
Add more columns. So now we're starting to do this. We're starting to say, I'll add a column, and I'll do cell phone. And then this will be work phone. And I guess we got to add in we'll add another column. And what other type of phone is there? Home phone. Okay. So what's good and bad about this suggestion?
Getting clustered.
We're getting what?
Getting clustered.
Well, okay, so now what we're doing is, well, first of all, we guarantee there's 3 the most number of phones someone can have. Can people have 2 cell phones? You got to know people have 2 cell phones, right? They're on. What? You have 2?
What?
Do you have 2 cell phones?
Yeah.
Yeah, all right, so this rule that we're coming up with where everyone has exactly 1 of each type of phone, well, either they have 0 or 1, might not apply to everybody. And just we'll go to an example later on. What we might do in our class is maybe if we made a store like Amazon.com and people are going to buy products from us and we're going to ship them to different places, we might have a a billing address and we might have a ship to address. And what if the person owns 5 pizzerias and they buy stuff on Amazon and they want to ship it to 5 different places? We might have to record all 5 addresses plus a billing address, like 6 addresses. So we're starting to get the idea that something like a phone, it's kind of, I wouldn't say unlimited, but there could be many, many versions of this column. So the suggestion of just making more columns, it works, provided we make enough columns for the person with the most phones. If one person has 8 phones, then I guess we have to make 8 columns for phones, and then we got everybody covered. And if a new person joins who has 9 phones, we have to add a new column, using that suggestion. What's the other issue? So one problem you said was, it's now getting wide, right? Now that's bad if a human being is going to go to this spreadsheet and start pulling answers out of it. But what we're going to do is we're going to have a computer come to a table something like this, not an Excel, but a table like this, and it's going to go start finding stuff. So computers work a lot faster than the human eye, so that won't be so much of a problem. But what's the other problem of making many, many columns to handle a case where most of our customers, most of our friends will have 1, maybe 2 phones, but if we make 8, they're going to have a lot of blank spaces, right? So we'd be taking up a lot of space to handle the one guy who's got tons of phones, right? So, and then we'd end up doing the same thing for emails too, right? I bet all of you have at least 2 emails, right? Well, definitely you do. The student one, and you have some other one that you do non-student stuff with, right? So you'll have at least 2 emails, and you probably have more, right? Right, when you're trying to pretend you're somebody else and you're emailing somebody, you gotta make a new email. So we're going to need email 1 and email 2 and work email. So the question now becomes, do we just keep making the table wider and wider, or is there another way you could think of doing this that would not have so much wasted space, like blanks, for people who don't have that type of phone or that type of email? And all we care about, so now don't worry about it being hard for a human eye to find the data. We're going to have a computer looking for it. So don't worry about how hard it is to find it with your eye. Just, we want to record the data. So is there any other way to handle the, let's say, 3 different types of phones for a person that you could think of? So I'll give you a hint. It doesn't all have to be in one table. You know, like in Excel, we can make multiple tables. So we can kind of have a table for the people, and then somehow have maybe a separate table for phone information, where we could say this person has this kind of phone and this person has this kind of phone. Something like that. Make sense? So what I mean is we could do something like this. Now here's where we need to have, for every person, we need to have something that kind of, well, does anyone have any other idea before we try that approach? So we already had one idea, make more columns. But that had the problem of that we're going to end up wasting a lot of space. And there's some error proneness to it. If somehow bad data gets into those empty spaces, we'll think that person has phone numbers they don't have. But is there any other idea you can think of where we could say for each person, we could, if they have 1 phone, we'll make 1 record that says they have 1 phone. If they have 5, we'll make 5 records. Another one we could have done. Sometimes some people suggest this. Let me get rid of these 2 columns. We'll go back to the way we were. Someone might say, why don't we make another record? If the person has 2 phones, we'll just say copy, paste, and then they have a different phone number. Right, so now we say Jerry Seinfeld has 2 different phones. We're just making a new record with the new phone number. And now we have 2 phones for that person. So this is another way of recording all the people and all their phone numbers. But what's the bad side to this idea?
You're repeating a lot of stuff.
We're repeating a lot of data, right? We're saying the same thing over and over. The other thing that'll open up is someone may change someone might go, oh, I'm spelling the first name wrong. It's with a G. They'd have to change it in every place, and they might change it in some and not others, and then he has 2 different first names. So we want to try to avoid the idea of repeating data, we're really doing is we're repeating this, and this, just to allow ourselves to have a different phone number. So is there something we could do that's like this, and like the adding the columns, but that there's no wasted space and no duplicate data? So it's kind of like making a separate table that just says, this particular person has this phone number, and this particular person has this phone number, and that's it, that's separate, and then the data about the person could be separate too. Yeah?
Are you talking about different spreadsheets?
Yeah. So if it wasn't, so don't worry about how complicated it would make it for a human being to look up a person's phone number. We'll say a computer's gonna do that. But we just have to teach the computer how to do that. But all we care about is storing the information. And we want to do it in such a way that we're not wasting, we're not repeating data, that's unnecessary. And we're not putting in a lot of blank squares to cover the fact that someone may have 8 phones and this person only has 1 phone, and then we have 7 blanks. So some way to kind of get the best of both worlds. But yeah, if we used another spreadsheet, what could we do? We could go like this. We could get rid of this column and take the idea that phones are really, there's multiple versions of phones, so we'll get rid of the phones. So this is the information about a particular person. Let me add a new person. How much understand? Okay. And I forget what address he uses on the show. But I'll just change it to something else. Okay, so we have 2 different people. Now, each of these people may have multiple phones. So what we can do is we can make the first sheet, we'll call this person, and then we'll make another sheet that's called phones. Now, all we're going to do in this table is record all the phone numbers for a particular person. So what do we have to do to record that one person has 2 phones? We have to somehow identify the person. So it'll be something like this, person ID, and then the type of phone, and then the number. So we're going to say, now we'll go back to table 1, and we're going to add something new. We're going to add an ID, a unique identifier for the person. We'll say this is person 1, this is person 2. And I'll make this tan. And then what I'm going to do is on phones, I'm going to say person 1 has a cell phone, and the number is 2. And I'll just make up a number. And then I'm going to say person 1 also has a home phone. And then, by the way, person 2 could have a phone, a cell phone too. And they have a number. Okay. So what I've done with these 2 tables now is I have one table that has information about the person. So this is just, and now what I have here is a unique identifier. So this is the new thing we had to add. And so, yeah, this is a good, if you get this concept, you'll understand the idea of how we're going to take 2 different tables, but they have to be connected to each other. So I'm saying person number 1 is Jerry Seinfeld. Here's his email address. Now I'm assuming everybody has only one email address, but we can make an email table separate if we think that's important. And here's their one and only address. Now I'm handling the fact that they may have multiple phones. So instead of writing a new line every time they have a phone, or adding new columns for every possible phone they could have, I just make a separate table for phones. And I'm saying person number 1 has, this table saying whoever person number 1 is. Now you might think, why didn't I write Jerry Seinfeld here? Why did I say person number 1? Well, Jerry and Seinfeld is a first name and a last name. If we just have a unique identifier, like a number, then we know to look into the other table and we can figure out who their name is. So now I'm basically saying that Jerry Seinfeld has a cell phone with this number, Jerry Seinfeld has a home number with this number, and then George Costanza has a cell phone with this number. So now, if I wanted to look up Jerry Seinfeld's home number, I'd have to go like this. It's a lot longer now than having it all on one sheet. I have to actually find the person I'm looking for, then get their number, their ID, then take that number and go to the other table. Go to the other table, and then look for the ID of one and the type of phone call, cell, and then I would return this and say this is the number I'm looking for. So does it make sense? The data's all there, but by doing this thing with separate tables, it made it more difficult for a human being, because you're clicking around, you're grabbing information from one table and then taking that information, running over to another table, then looking for a field where that number exists, and then returning another field. It's harder to do. It's harder to take to get the information you want, but the way we've stored it is organized. Right? We're not wasting space. We're not repeating data. We're not prone to having errors in our data by doing this. And then obviously we could do the same thing for any other field we wanted to. For example, emails. If we decide that people can have many emails, we might take this column out and make a separate table for emails. Right? Same idea. Then we'd say person number one has this email, this is their home email, this is their work email, and so on. So it kind of makes sense that this is a good way to store the data, but it'll give you a headache. If I said to you, what is Jerry Seinfeld's email and cell phone and all that, you'll be jumping around from table to table. It'll take you a while to gather up the data. But if we could we're going to now start calling a collection of tables that have data that is related to them. The entries in the tables are somehow connected to other tables. A collection of tables we're going to call a database. If we have a collection of tables of related data, and then programs that can actually, we could ask questions like, give me all the cell phone numbers of everybody. It could spit that out. Or if we say, give me the home phone number of a particular person, it'll spit that out. That'll end up being a database. So that's kind of an informal definition of a database. So Excel is not really geared for organizing a database. So what was our next slide? Okay. So we would need something that, we would need to somehow have a mechanism where we can set up tables, name the columns in the table. The other thing is, like when we did that trick where we had a unique identifier for each person, that particular column should have a property that we never put in the same data for any person, right? We don't want Jerry Seinfeld to be person number one. And then Cosmo Kramer is also person number one. It'll confuse all our data. So we might want to have some columns that are what we're going to call a key, meaning it must have a unique field for that table. If you ever try to put in the same data, same value for another person, it'll tell you, sorry, that one's already taken, pick a unique number. So that won't happen in Excel. You can't say to Excel, I want these fields to all be unique. Okay, but then the most important thing is we want to, once we have all our data organized, we don't want to use our eyes to go looking for people's phone numbers. We want to be able to submit a one-line command that just fetches us that stuff. And let the database system fetch the information for you. So one of the most interesting things is this programming language called SQL. So SQL is basically, it stands for Structured Query Language. And it's a programming language that operates on all types of relational databases. So for example, we might want the first name, let's say for example, as you can imagine now, we might have, if we're running a business, we might have one table full of customer information. Like let's say, for example, we're running this example, I think it's like a spa. Okay. So let's say we're running a spa and we have customers come in for manicures and pedicures and massage and haircuts and that kind of stuff. And we decide that we're having a sale on pedicures. So we would like to know the email addresses and the first name of all the customers who have ever made an appointment for a pedicure since we opened the business. because we'd like to send them an email. Dear Mary, on Saturday, we're having a sale. So we'd like to have a nice report of the first name and the email address of all the customers that hit that category. So the way we'd end up saying it is, and it's typical to write this in 3 lines, but you could write this all as one big line. So basically I'm saying, select the first name and the email address from, and now at this point we could just list out the tables that are connected to each other. What I mean by connected to each other, it's like the last time I had a person and a person ID, and then there was a column with the person ID. So I'm basically saying, select the first name, email address from our customers. So our customers in this example would be a table that has the customer's first name, last name, email address, phone number, all that stuff. And we have a table full of appointments. That means this customer met this person on this date at this time for this service. And that would be another table in our database. And then we say where appointment type equals pedicure. Now, if we did that with our eyes, it would be pretty painful, right? We'd have to go through the appointment table, look for everyone that says a pedicure, then look who the customer ID is, then go back to the customer table, find that person's name, and print it out. But the database system, as long as it does this, has this SQL language, we could just type in this line. It's really 3 lines, but I could type it as one long line. And just hit enter, and the result will come out. It'll say, it'll print whatever you call the headings. It'll say first name's Mary, this is her email. Next name is Sue, this is her email. And then we could even have a program that then takes these things and just shoots off an email to these people. So it'd be like one button. Once we have our data perfectly organized, we want to take our data, organize our database perfectly, and then we could ask the database a series of questions like this. And then just in one operation, all the data comes back and we shoot off an email. So, okay, so Microsoft Access is one example of a database management system. It's a desktop database system, so it's meant to be run on a PC. And we can create tables with keys. That's where like a column has to be a unique identifier, if we wanted to have that. We could do lookups on fields in other tables, and then generate queries and forms for reports. So I'll kick off just a simple example of so let me I'll do a brand new Microsoft Access database. What should we call this? We'll call this, let's call this Friends. Okay. So what this is going to do is, we're going to, let's see. Okay, I'm used to this thing opening and putting us in a position where we can create a table. It usually opens up like this. Okay, but anyway, what it's doing now is right away it makes the assumption the database is no good without any tables or any data. So the first thing we want to do is start making tables. So now what we can do is we could say, let's make a table. It actually gives us the name table 1. We could change it later. I think Access gives you like does a little too much for you. Wouldn't you expect it to open up and say, what would you like the first table's name to be? And you type it in. What would you like the columns to be? You type those in and then start typing the data. I don't know if intuitively that's what I would have expected. This thing's saying it already named it table 1 for us. It already gave us an ID field, whether we like it or not, so that's a unique identifier for it. And then it's going to give us names like field 1, field 2, field 3. It wants us to start typing in the data. So I think it gets a little ahead of ourselves, but I can say Jerry Seinfeld. Say we'll do one address. Okay, so that's the address. I'll stop it right there. I could go to the next line. And do the address after. So now we have two people. Now, what Microsoft did, not exactly sure why, I don't know where they get their starting number, but this became the identifier became number 3 and the identifier became number 4. Other database systems will allow you to have the option to put in an identifier. Remember what the purpose of the identifier is, so any record that's in here has a unique number to it. So I can always tie this table to any other table by putting the ID column. So other database systems, like I was saying earlier, that, you know, learning one database versus another, a lot of times is like learning how to drive a car. If you know how to drive a Ford, you know how to drive a Chevy. There might be a few gadgets that are different, but, so this is one of the ones that's different. In Microsoft Access, they automatically give you an ID field with a unique number, and they generate the number for you. Okay. Now what we might want to do is change the names of the tables to have more appropriate names in the field. So the field on top, I'll call this first and last and address. And if I go to save it, I can rename the table. The table will be person. Okay. Now we'll do that trick like we did before. We'll create a new table. And now here's a second table, which they're now calling table 1 again. And now I'm going to make a field called person ID. So I'm going to make this be a lookup table. That means the only acceptable values are, see, like so far, like Excel, we could have typed anything we want. Jerry and Seinfeld, we can type anything and it'll take it. Now what I'm going to do is make this. You can set a field to say the only acceptable values are values in another table. So I'm going to say lookup fields from another table, yes. I want from person, and I want the ID of the person, and ascending order is fine, it's the way to list out. So right now, the only acceptable values to put in here are 3 and 4, which are the unique identifiers for the two people in our database. So what that means is, and I'm going to call this person ID. And now I'm finished. And the table's name will be phones. Okay, now I could make this the phone type and the number. Okay. And then I could say, so person ID would be person 3, which is now Jerry Seinfeld. And then I could also say person 3 has a home phone of some number. And then I could say person 4 has a cell phone of some number. Okay, so this is the same thing we just did in Excel, except now we're doing it in Access. But so now, what we're doing is, so here's the interesting thing. Access always gives you a field called ID with a unique identifier. And now I'm saying, in this table, I'm identifying a particular person and saying it has this type of phone and here's the number. So now, it would be, to look it up would be the same. I could ask a question like, give me all of Jerry Seinfeld's phone numbers. And then it would list out, actually I should name these fields. I should call this phone type. And I should call this one number. And now I could just say select, I could write that SQL statement that says select number, I want to see the numbers. I'm sorry, select name, type, and number from person and phones where the person equals Jerry Seinfeld. Person first equals Jerry Seinfeld, and person last equals Seinfeld. You know? And then it'll generate a report of all of Jerry Seinfeld's phone numbers. Or I could generate a report of all different people's phone numbers. Any type, we could ask any type of question about these databases. So, and we can make as many what we're going to call queries as we want. So let me just save this one. I'll kick off a, here's another, so the access databases end up in having an extension called ACCDB, which is short for Access Database. So this is an example of what we did in our IT 100 class. This is for a spa. So this would be, so for example, we have, this was a spa we were creating a database for. So for example, we have customers. So the customers have a last name, a first name, an email, a cell. So we didn't handle the case where they have multiple phones and multiple emails. We required all our customers to have one phone only. So maybe we could ask them, what's your favorite phone to use? And that's the only thing we record. Then we have what the students call artists. So the artists would be the people who work for our spa. So they have a first name and a last name. And there are services that they provide. Okay? And then we had the services we provide. So we had another table for services. So we said we provide hair, nails, and massage. Here's the price of those, and here's how long they take. So we would record information about each of the services that we provide. And then we have appointments. And appointments would have, so each appointment has a unique identifier. The appointment would have a customer, the artist, the person who's, the employee who's performing it, the service they're providing, the date they're doing it, and the time they're doing it. And every time we make an appointment, we add a record to this table. And now, with these 4 different tables in our database, we have appointments, artists, customers, and services. And like we said before, the customers could get broken up into many subtables if we wanted to have a separate table for phones and addresses and email addresses. That's our own decision to make. We can now ask questions about all of these tables. And in fact, we'll have a bunch of queries. So queries are commonly asked questions that we'll ask a database. So one particular question we could ask is this one, customer appointment. So I can click on this, and it says, give me, it's asking me to enter a customer's last name. And if I enter the customer's last name and hit OK, it will go into the appointments, pick out the person's last name, then go and get the person's first name from the customer's table and print out who the appointment is with, and we'll go to the artist table to print out the person's name, who their appointment's with, and what their first name is, and print that table out. So I'll type in, I think I used mine. And this now generated a report. This is not a table, this is a report that's basically saying, this customer at this cell phone with this artist has a massage coming up on this date at this time. And if you wanted to see the, you can go to the design view for building the query. So this is only in Microsoft Access. Other databases don't have a different kind of design tool for this. But what we're basically doing is we're building the SQL for what we're looking for. And we're basically saying, list out the last name from the customer table, the cell phone number from the customer table, the artist from the appointments table, the service from the appointments table, the date from the appointments table, date and time from the appointments table. And this check mark is saying I want to see it in the report. And now I'm saying for the criteria, I'm saying where the customer equals, and at this point, this is a Microsoft Access thing. If you put in brackets a question, the question will pop up. And whatever the person types in, it says where this last name is the name used in both of these tables. And for this particular query, this is called the query design panel. It's basically saying we're using the customer table and the appointments table, and the customer ID matches the customer name. That the two tables are connected because the customer in the customer table and the customer name in the appointments table must match in order for this answer to come out. And so with Microsoft Access, you can actually, instead of typing in that SQL statement where it said select and then all the column names from, and then you list out all the tables that are connected to each other, and then where, and you say where the customer name equals a particular name. Instead of doing that, you could pop this screen up and just start putting in like checkboxes and how you want to build it. And Microsoft Access builds it for you. So I think there's a way to say the SQL view. Yeah, the SQL view. So the SQL for this statement is right here. So this is really the SQL statement that graphical interface just built for us. So we're saying select from the customer's table the last name, comma, customer's table the cell number, comma, from the appointments table the artist name, from the appointments table the service name, from the appointments table the date and time, and from the appointment table the time. From, and we're saying the customer is having an inner join, don't worry about what that is, that's a little down the road in the database then. Inner join with the appointments on the condition that the customer ID equals the appointment's customer name. And then, so that's which rows from the two tables that are linked together. And then we want the one where the customer's last name equals whatever the person entered. Okay, so in the end, what we want to do, every database system you'll ever use has a way for you to create tables, has a way for you to make columns in the tables linked to columns in other tables, and then allows you to run this SQL statements. If they happen to have ways to build the SQL for you, that's great, but if not, you know, you could always just cut and paste off of Google. So, so that's an example of how Microsoft would do it. And then Microsoft, like I say, is a desktop database. So if you create a database in Microsoft Access, it can only be used on the computer that's in front of you. We would like to, in our class, create a database so that your web page can connect to the database through the internet, ask for data, and bring it back. You know, what is this? I have a person, what is his password? I want to see if it's the correct password. Or a customer is looking to print a web page with all the furniture that we sell, or all the bathing suits that we sell. We don't want to print out every piece of merchandise we have. They're looking for a specific one. So we would put a SQL query on the database that asks the person, what type of merchandise do you want? And they would ask and say, swimsuits. And then we would give them all the swimsuits we have, and then that would display them on the web page. So we like to focus on online databases. And then there's also some problems with integrity with databases. So for example, this is stuff like if you took a full semester database course, they'd cover topics like this. But it's just something I want us to watch out for. For example, in that appointments calendar that we did before, it is possible, the way that database was laid out, I could book the same employee at the same time. I could say I can make an appointment with the employee at such and such employee at 2 o'clock on Wednesday. And then later on add another appointment because I don't have it blocked that you can't schedule the same person at the same time. Database doesn't know people and time and haircuts and massages can't be done simultaneously. It doesn't know that. We know that, so we have to program that into our database. Another one, this is an example on the topic of putting databases in normal forms. For example, we could have a database where we have like a tennis tournament, who the winner is, and what the person's date of birth is. So the Australian Open in 2012 was won by, does anyone know how to pronounce this thing? Anyone like tennis? Djokovic? So anyway, that's the one. And then this is who won the US Open, same guy. And then the French Open was Nadal. The problem with organizing, you might think this is a good way to set up your table. You have the tournament, the year, the winner, and the winner's date of birth. The problem is, it's possible to enter a different date of birth for the same person because we're not saying, we have no rule that says this field must match this field. because these people match. If the person matches, the date of birth must match. So we as human beings, we know that every person only has one date of birth. But our database, we could set it up in such a way that we give 2 different date of births for the same person. So it's just something just in the back of your head when you're creating your tables. You might want to instead separate it. Again, a lot of times separating the tables solves some problem. We have the contest, the year, and the winner, and then we have the person and the date of birth. This way we only record the date of birth once. But we have it in 2 different tables, but that SQL language will be able to find everything we ever need. And some well-known databases are desktop databases are Microsoft Access, which is made by Microsoft, FileMaker Pro, which is made by a company called FileMaker, and then FoxPro is a pretty popular Microsoft product used in industry. But server databases are like SQL Server, which is also made by Microsoft, pretty popular one. Sybase, which is made by a company called Sybase, Oracle, which is made by a company called Oracle. And then a really popular one is MySQL, which is open source, meaning it's free. It's currently owned by Oracle, which bought it, well actually it was made by a company called MySQL AD, which was bought by Sun, and then Sun was bought by Oracle, so it's now currently owned by Oracle. And it's part of the XAMP technology, which is basically all the stuff that is free. Have you ever heard the expression LAMP technology? Okay, so that stands for Linux, Apache, MySQL, and PHP. And now it's generally called XAMP because instead of requiring it to be Linux, it could be any type of computer, any type of operating system. So it could be Windows or Linux. But these are all the technologies that are free. So if you wanted to start your own internet company, you could do that. And all the technology you'd be using is free. So a lot of times you'll hear a company will say it uses LAMP technology, which basically means it uses everything that's free. And if you go to Facebook, I know a lot of you guys don't believe stuff unless you see it on Facebook, but if you go to Facebook, what the jobs they're looking for, you go to, I guess, engineering. Okay, so here's the job title. See, this I find strange. I didn't think Facebook would do this. This is looking for a MySQL database engineer and a MySQL database engineer in Dublin. What I find strange is that they would require you to know the particular database, MySQL. Because, some people argue if you're good at one database and you know SQL very well, does it really matter which database it is? I mean, obviously it would be nicer if you know the exact one they're using, but some people argue that knowing a similar one, you'd have basically the same set of skills. So they'd like you to know how to write code in PHP, some shell scripting, which we've kind of done, Linux administration. So yeah, one of the responsibilities, develop or augment an existing framework to automate as much as possible the administration of one of the world's largest MySQL installations. One of the largest MySQL installations in the world. So Facebook was started using all the free technology, because it was started by a kid in a college dorm. So the problem is it got so big so fast, you wouldn't be able to switch it to one of the more expensive databases like Oracle, because what day do you pick to switch it? What day do you shut the site down? Copy all your 500 million users over to the new database, turn that back on, and hope it works. There's no day they'll be able to do that. So it got started using MySQL as a database, and it's pretty tough to remove that now.